This is a question taken from a previous Stanford Mathematics Tournament question. Now let me do my way of integrating this integral. First, this cosine 2x, we have a couple of formulas for cosine 2x, right? Now here I'm using 2 cosine square x minus 1. So by plugging this identity into the integrand function, then we get integral from 0 to pi, and the denominator becomes 2 cosine square x plus 2, right? And on top will be 2x sine x dx. Okay, now here we have a 2, 2, 2, so it could be cancelled out. So it is equal to integral from 0 to pi. This is x left, right? And cosine square x plus 1. And sine x dx is the derivative of cosine x, right? Negative. I have a negative here. So negative d cosine is x sine x, yeah. The reason I'm writing this way, I'm prepared for the integrated by parts. This is negative 0 to pi, and x. Now this is the derivative of arctangent. This is the derivative of arctangent cosine x. Yeah. Good. Now obviously this is my u, this is my dv. I can perform a integrate by parts. So this is equal to negative bracket uv. This is my u, this is my v, arctangent cosine x, right? From 0 to pi minus integral v du. Too many brackets, this is not there, okay. Minus integral from 0 to, this one is v du, this is my v, right? Arctangent cosine x. And my dv, my du is a dx, okay? Yes, this is good. Now this is a negative, this is pi, right? Cosine pi is a negative 1. Negative 1. Arctangent negative 1 is a quarter pi. So pi times negative quarter pi. Minus this one. I have to do separately. Arctangent cosine x dx. Yeah. So this one is equal to pi square over 4 plus this integral arctangent cosine x dx. Okay, so I'm doing this integral now. This is from 0 to pi, arctangent cosine x dx separately, okay? Here I'm using substitution. Let u be arctangent cosine x. So tangent u will be cosine x, right? And then differentiate both sides, secant square u du is equal to negative sine x dx. So my dx is equal to negative secant square u du over sine x. Okay, so my integral becomes integral u negative secant square u du over sine x, and then we have to change the boundary, right? So when x equals 0, tangent u is 1, so u is a quarter pi. When x is a pi, when x is equal to pi, so this is a negative 1. Arctangent negative 1 is a negative quarter pi. Okay, so this becomes a... Now we have a negative here. This negative, I switch the limit, right? This is a negative quarter pi to positive quarter pi now. The negative is gone. And this is u. This is secant square u du. And x sine x is a square root 1 minus cosine square. Cosine square is tangent u. Therefore, it becomes tangent square u. Okay, good. Now, this integrand function, this is a square, this is a square, this is a u, not a square. Therefore, this is order function. So, for this equal to 0, see? This is order function, square, square, not square. Then integrate from minus quarter pi to positive quarter pi, it will be 0. So our integral, our integral is equal to pi square over 4. This is 0. So that is my very answer to this integral. I believe this is a very nice way to integrate this, to do this integral, nicely, and not too many steps. Thank you for your watching.